Okay, we're going to try to extend what we have learned about right triangles and trigonometry into the coordinate plane. So I have this coordinate plane sketched, and I also have this triangle. Now, a lot of times what you'll be given here is you'll be given a point. For example, you might be given this point here, and they might label it as, let's say they say this point is the point 4, 3. If this is the point 4, 3 over in this corner, they might want you to find some trig functions associated with that point. Well, the first thing you need to realize is that point, they're going to talk about this line here that connects the origin to that point, and the angle they are talking about is always this angle here. The angle they talk about always starts at the positive x-axis and goes in this counterclockwise direction toward the line. So that's the angle theta, and you can see I've already shaded in a triangle here, and that's what our trig function is going to be based on. Here's one thing I do want to point out. When I'm talking about my trig functions, this is still the hypotenuse, this is still opposite, and this is still adjacent, because that is the side here that I'm marking in yellow is the side that is next to theta, and the side here that I'm going to mark in orange is the side that is opposite from theta. However, when we're on a coordinate plane, not only can I call this yellow side A, I can also call that yellow side X, because it is the X coordinate that gives me the length of the opposite side, because that point 4, 3, I had to go over 4, so that in this case, the length of that side is 4. It was the x coordinate of my point. The opposite can also be called y, because the y coordinate of that point gives me the length of the opposite side. So in this case, it's 3. Now, I can find the trig functions any way I want, but it's just kind of a shortcut to know that the x coordinate is always the adjacent, and the y coordinate is always that. And sometimes instead of the hypotenuse, they also call it the radius, because if I set up a circle in the was centered at the origin, it would have a radius there. And I'll just kind of show you what I'm talking about there. If I took a circle and kind of drew out from there, this point there would be the radius of that circle centered at the origin. So that's why they call it the hypotenuse or the radius. So when you see this x and this y and this r, they're just basically using our old familiar opposite, adjacent, and hypotenuse and translating into a coordinate plane. So that means if I go to get my trig functions, if I want to do sine of theta is still opposite over hypotenuse, but sometimes you might see it written as y over r, because y on the coordinate plane is the opposite side of 3, and r is, well, I haven't found the length of r yet, but if I notice this is a 3, 4 right triangle, so the other side is 5. Pythagorean theorem could confirm that, but it's a 3, 4, 5 right triangle ratio, so my r value is 5. So I have 3/5 for my sine. If I wanted a reciprocal that goes with sine, since sine has an s, I need the one without an that doesn't start with an s. Cosecant would be the reciprocal of sine, 5/3. Then if I wanted cosine of theta is adjacent over a hypotenuse, but in this case, they might write it as x over r. And that would be the adjacent side, or the x coordinate would be 4. And the hypotenuse, or the radius, the distance from the center, would be 5. And that means if I was looking for the reciprocal function, since cosine has a c, I look for the reciprocal without a c that doesn't start with a c, which is the secant, and that is 5/4. And then finally, tangent is opposite over adjacent, but in this case, on a coordinate plane, the opposite is the y and the adjacent is the x. So I'm always going to have the y coordinate over the x coordinate. So in this case, that is 3/4, because the y coordinate, the opposite, was 3, and the x coordinate, the adjacent, was 4. That's an ugly x, but that gets the job done, I guess. And then last but not least, my cotangent. My cotangent is the reciprocal, so flip it upside down. Instead of 3/4, I have 4/3. And that is sine, cosine, tangent, and the reciprocal functions, all from a point on a triangle.